Welcome to my talk. I'm stoked to be virtually presenting from lovely Hawaii. So today, let me introduce myself and then we'll dive into what we're going to be talking about today. So my name is Patrick Wardle. I am a principal security researcher at Jamf and the creator of the Mac security website and tool suite, Objective-C. So today we're going to be talking about malicious documents, those specifically targeting macOS. So first we'll detail recent attacks targeting macOS that did so via macro-laced documents. We're then going to discuss methods of analyzing such documents, how to extract the embedded macros, and how to analyze the document payloads. And then finally, we're going to show that current attacks are somewhat constrained, somewhat limited, kind of lame in a way. So we're going to end by showing a new attack in the exploit chain that combines, which was a bunch of 0 days to bypass the Office sandbox and also Apple's latest security mechanisms. All right, so let's dive in, and we're going to start by looking at some recent macro-based attacks that were targeting macOS users. So first, let's define what a macro is. Some of you may already know, but it's important that we're kind of all on the same page before we move on. So as we can see on the slide, I've added the official definition from Microsoft. But in short, you can think of a macro as embedded executable code in Microsoft Office documents. And this code is normally VBA. So in other words, it allows you to add code to a document. So here, for example, I've inserted a macro into a Word document to display a simple pop-up that just says, hello world. You could do that in about 3 lines of code. And we'll talk about this more, but as we place this code within the auto open subroutine, if the user has enabled macros and opens this in a Microsoft Office product, this code will be automatically executed. Now, from a security point of view, allowing executable code to be embedded into documents is a terrible idea. And this is something that attackers have abused for years, for decades. In fact, the infamous Melissa virus, which was all the way back in 1999, so last century, yes, you guessed it, it abused macros. It was a macro virus. Now, I do want to point out that Microsoft has added some mitigations, such as alerts and sandboxing, but we'll see that these ultimately don't fully mitigate the threat. Now, traditionally, macro-based attacks have targeted Windows systems predominantly for 2 reasons. So first and foremost, macros are a Microsoft creation. That is to say, they only actually work, they're only actually executed within Microsoft products. So Apple Office apps, for example, Pages or Numbers, are not vulnerable. They don't understand, they're not going to execute macros. Then also, Windows computers in the past were far more common, far more prevalent, especially in the enterprise. However, this is all changing, especially in the commercial space and in startups and tech companies. In short, there are now far more Macs becoming very prevalent, as I mentioned, in the enterprise. And they're also now running a lot of Microsoft Office products. So targets are very opportunistic and have seen this as a great opportunity to target and infect more systems. Now let's look at some recent attacks that have leveraged macro-laced documents. So this first section, we're going to kind of look at high level. And then the next section, as I mentioned, we will dive in and describe exactly how to extract and analyze the malicious payloads in these documents. So again, high-level overview here. So starting in 2017, we have a document that, based on its title, appears to be about Trump's rather unfortunate election victory. Now, when this document was open, if the user clicks enable macros, since it had some malicious code embedded within it, the system would be automatically infected. Moving on to 2018, we have a document that, again, based on its title, appears to be about Bitcoins, which was a very hot topic at the time. If a user was tricked into opening this document and, again, allowing the macros to run, the system would be owned. Now, we'll dig into this attack a little bit very shortly because it had a really interesting aspect, and that was it actually contained exploit code to bypass Office's sandbox. On to 2019, we have a document from the prolific Lazarus group, which is normally attributed to North Korea. And it's interesting to see now that APT groups jumping on the, let's target macOS users via macros bandwagon. So I think they've seen the success of this technique, this attack vector, and so they're developing capabilities as well. Again, if the users open this document, clicking allow to enable macros, the system would be owned. User would be infected. So now let's take a little bit more of a technical deep dive and talk about methods of analyzing the embedded macros, starting with how to first extract them. So I mentioned, first thing you need to do is to actually be able to extract the malicious macro code. If you, for example, suspect a document is carrying some malicious macros or ultimately some macro-based exploits or payload. Now, due to time constraints, we can't really dig into the file format of Microsoft Office documents, but the good news is you don't really have to, because there are several great tools that are available to extract the embedded macros from these Microsoft Office documents. My favorite tool is called OLE Tools. It's available open source, free on GitHub. And as we can see on the slide, when you download the package and install it, there is a command you can then run called OLE VBA. And if you execute it with the -C flag and pass in the path to the document, which contains the macros, it will parse the document and dump any embedded macros. That's great. Does all the work for you. Also, I should mention there's various online sites that allow you to upload a Office document that contains macros, and the website will automatically extract those and then allow you to analyze them. So now we understand exactly how to extract the embedded macros in these malicious documents. Let's briefly talk about the payloads, specifically focusing on the documents we just mentioned in the previous section. So again, starting back at the one in 2018, if we use the OLE VBA command, we can extract the macros. And as we can see on the slide, we see a subroutine in the macro code called Fisher. And Fisher is invoked via the auto open method. Mentioned earlier, this auto open method is a Microsoft API. And as its name implies, if code is placed within this subroutine, it'll be automatically executed on the document open. Again, only if the user though clicks allow macros. Now this Fisher subroutine does two things. It builds a base64 encoded string and then decodes and execs that via Python. So if we manually decode the string, we can see that it turns out to be Python code, which makes sense because in the macro code, they're executing the decoded string by passing it and then passing it to Python. So what does this Python code do? Well, we can see on the slide, it does 3 or 4 different steps. First, it checks to make sure the popular macOS firewall, Little Snitch, is not running. It then downloads a second stage payload from securitychecking.org. It then decrypts this payload and executes it. And if you've done a lot of analysis of this kind of stuff, this code might look familiar. And the reason is, it's because it is a well-known open source Python backdoor named Empire. Find this on GitHub, look at the code. Now, you might be wondering what the second stage payload is or does. Unfortunately, the command and control server was offline by the time I got a copy of this document to analyze, but it's likely simply just Empire's second stage payload, which gives attackers full access over the infected system. Next, we look at the Bitcoin document that had the malicious macros embedded in it. Again, via the OLE VBA command, we can dump and extract the embedded macros. Again, we see this document, though unrelated to the first, also contains encoded Python. And if you look a little further, though, it also appears to contain perhaps an embedded property list, plist file. This is strange. So let's take a closer look. We can first decode the Python, base64 encoded. So I've manually decoded that. You can just pop into the Python interpreter, import the base64 module, and then pass the base64 encoded string to the b64 decode function, and then Python will nicely decode it for us. So if we follow these steps, print it out and kind of formatted the Python code, and we can see on the slide, we can see that it connects to a server at 109.202.107.20, and then it downloads and executes a second stage payload. This IP address was still live, so I was able to go grab that second stage payload by executing this in a virtual machine, and it turned out to be Metasploit's Meterpreter, which is another well-known open source post-exploitation agent that again affords remote attackers complete access to an infected system. Now, we noted that one of the interesting components of this was the fact that it had the ability to escape out of the Microsoft Office sandbox. And we're going to be talking about the sandbox a bit, but in short, recent versions of Office run in a sandbox. And this is good from a security point of view because it means that even if malicious code, for example, macros, are allowed to execute, they will still be highly constrained. They'll be very limited by what they can do. For example, they won't be able to persist the binary. They won't be able to access the keychain users' files, right? The sandbox is basically a jail, contains within it. So a lot of hackers are going to try to break out of the sandbox so that their malicious code can perform some more destructive activities. So a security researcher named Adam Chester found a very neat way to escape Microsoft's sandbox and posted about it on a guest blog on my website, objectivec.com. So in short, he found a sandbox exception based on a faulty regex, which we can see on the slide, that allowed the attacker or malicious code within the sandbox to create specially named files anywhere on disk. Normally this, the sandbox should prevent the creation of arbitrary files. So what he was able to do was create a launch agent, which on the next login would be automatically executed running outside the sandbox. So it's kind of a neat logical attack to escape the sandbox. And again, once you're outside the sandbox, you can persist binaries, access user files, really have full access to the system. So it was interesting because the attackers clearly read the blog post on Objective-C, copy and pasted Adam's code verbatim into the malicious document. And when we dumped the macros, we could actually see the exploit code that Adam had written. So kind of interesting to see attackers paying attention to what security researchers are doing and then utilizing that in their own attacks. Finally, if we extract the embedded macros from the final documents, the one from 2019, we can see it's a fairly straightforward, unencoded macro code. What does it do? Well, it simply downloads and executes a second stage persistent implant. This implant is named mt.dat. And what it does is it gives the Lazarus group attackers persistent remote access to the system. All right, so that's an overview of recent macro-based attacks, which I think gave us a fairly thorough understanding of kind of the status quo, right? Where the bar is, what attackers are doing. But now let's kind of switch gears and talk about a new zero-click macro-based exploit chain. You might be wondering why we want to do this. And the reality is current attacks, as we can see on the slide, are rather lame. So first and foremost, if a user opens a document that contains malicious macros, those macros will be blocked. Office will show an alert, and the user will have to click enable macros manually in order for the macros to be allowed to execute. Now, most users won't do that. So that means the macro code probably doesn't even execute. So the attack is stopped right there. Also, Microsoft has patched Adam's sandbox bug, so all current attacks remain sandbox, which again really constrains what they're able to do. And then finally, in Catalina, due to quarantine and notarizations, payloads, even those executed in the sandbox, may be blocked. So in reality, current attacks are almost kind of useless. They're very unlikely to succeed. Now, whenever companies such as Microsoft or Apple patch something or implement a new security mechanism, I always like to poke on that. So let's walk through the exploit chain. Now, the exploit chain starts with a very neat bug that was not my own. It was found a while ago by two other security researchers and some other researchers at CERT. They found that even if macros are turned off, they could create a document that contained malicious macros that would be automatically executed with no alerts, with no prompt. How? Well, they figured out they could abuse a really old file format from the 1980s called SYLK and write macros not in VBA, but in something called XLM. Not XML, XLM. Very kind of old macro-based programming language. Now, luckily for us, Microsoft loves to support old file formats for compatibilities. So yes, these file formats are still supported by even the most recent version of Microsoft Office, especially Microsoft itself. So the researchers found that they could write XLM macro code that again would be automatically executed, ironically, if the user had set macros to never run. So the most secure settings. The researchers published some great information about this bug and these file formats. So if you're interested in more details, check out the link that is on the slide. So what I did was I took their bug and I started by writing a simple proof of concept. So what we're going to see in this brief demo is we're going to see a malicious document that is downloaded from the internet, and then it is opened, calculator is going to be automatically launched. And note that there are no alerts, no pop-ups, nothing asks us if we want to run the macro code, simply an Office document that gets open and our commands, our macro code to spawn calc is run. So progress, this is great. Now I noted that Microsoft Office is sandbox. So even though we can spawn calculator, that's almost in a way all we can do, right? We can't persist the backdoor, we can't access users' files. Really, that's the point of the sandbox. So we need a sandbox escape, a new sandbox escape, in order to do any real damage. So I started by looking at Microsoft's patch for Adam's bug. And interestingly enough, they didn't actually fix the faulty regex. They just blocked certain locations, such as the ability to write a file to the launch agent directory. And we can see that at the bottom of the slide. They basically added 2 file, write, deny rules. So this means we can create arbitrary files on the file system as long as they start with $$. That was kind of the constraint of the regex. And as mentioned, almost anywhere. Not the launch agent directory though, but other places. And we're going to see this is kind of one of the keys that allow us to ultimately own the system. Now, the goal, of course, is to be able to execute something outside the context of the sandbox so we can persist, install malware, do all sorts of evil things. We just noted that we can still write specially named files to arbitrary locations, as Microsoft didn't fully patch them. Turns out in the sandbox, via macro code, we can also download and execute scripts, as for example, we can see in the process monitor. Now, these scripts will be sandboxed as they are children of a sandbox parent. So they are automatically also constrained by the sandbox. But this is a start. We can now download and run Python code, even though we're still in the sandbox. So what we can do is via a Python script that we can execute within the context of the sandbox, turns out we can create something called a login item. Now, a login item is automatically started next time the user logs in. And the key is it's automatically started by Mac OS, not by us within the sandbox. And when it is started automatically by Mac OS, it is running outside the context of the sandbox. Hooray. So we can confirm this by persisting, for example, terminal.app. And then on next login, if we go look at the activity monitor process list, we can see that terminal has been automatically started and it is running outside the context of the sandbox. However, we then run smack into Catalina's new security mechanisms, specifically the notarization requirement. In a nutshell, on Catalina, Apple basically says we need to examine and bless any binary before it is allowed to run if it's coming from the internet. This means if we place a backdoor directly in our document or download it from the internet, yes, we might be able to persist it, but then as soon as it's executed, Mac OS will detect that it's not notarized and will block it. And unfortunately, we can't remove the quarantine attributes to get around this. So again, this is another obstacle we have to address. But hope is not lost if, and this is a big if we can create a launch agent, we can create a persistent interactive non-sandbox reverse shell via bash. Now, this will be allowed to run because bash is an Apple process, so it's not going to be constrained by the notarization requirements. And then via this shell, again, in theory, if we can create this, it will allow us to download other binaries outside the sandbox. And these binaries will not be constrained by Apple's notarization requirements because bash does not apply the quarantine attributes. And the quarantine attribute is what kind of triggers the notarization checks. But recall, unfortunately, Microsoft's patch specifically prevents the creation of launch agents. So we have all the potential pieces. We just need to find how to put them all together, right? So we can escape the sandbox via a login item, but login items can't take arguments. And we can't persist a random binary because we'll run into notarization. So in other words, we can only persist Apple binaries with no arguments. And sure, we can bypass notarization via a launch agent, but we can't create one from the sandbox due to Microsoft's partial patch. So in other words, what we need to find is a way for the system, the way for macOS, for an Apple binary with no arguments to create a launch agent for us. This seemed like a rather insurmountable obstacle, but kind of had a random epiphany that turned out to work. So I had this random idea. What happens if you persist a login item that is not an application or a binary? Like, what happens if you persist a zip file? Recall again, this is something we can do from the sandbox, and whatever we persist will be automatically run the next time the user logs in. But what does it mean if you persist a zip file? Like, what is going to happen? Is it going to get ignored? Is it going to get run? Well, it turns out on login, the file's default handler will be invoked. And for a zip file, macOS will automatically invoke Apple's archive utility to unzip the file. Now, remember, we can't create a launch agent, but due to Office's custom sandbox rule, we are trying to create a launch agent, but we can't write directly to that directory, right? That will be blocked. But if that directory doesn't exist, which on default versions of macOS it does not, we can actually drop a zip file one directory up in the user's library directory, and this will be allowed by the sandbox, right? Because we're not writing to the launch agent directory, we're writing one directory above. So what do we put in the zip file? A directory named launch agents. And in that, we then add our launch agent property list. So if we persist this zip file as a login item, which we are allowed to do, on the next login, the archive utility will be automatically invoked by macOS, and it will unzip this archive. Since it's in the library directory and creates a launch agents directory, it will then create that launch agent directory and ultimately put our launch agent plist in the correct location. On the next login, launchd will automatically process this launch agent plist that we created, which contains our interactive bash backdoor. So here's the entire exploit chain. The user opens the SLK file, which contains the XLM macros that are automatically executed. No pop-ups, no alerts. Our macro code then downloads and persists this specially crafted zip file as a login item. On next login, the archive utility automatically runs outside the sandbox, processes this zip file, which, because it's specially crafted, creates the launch agent by first creating the launch agent directory and then the property list that we need. On the subsequent login, the launch agent gets run with our arguments and executes our bash-based interactive backdoor. So this is the example of the property list, as you can see on the slide. This is what ultimately gets persisted. As I mentioned, launchd automatically executes these launch agents, again, outside the constraints of the sandbox. And we can see what we do is we execute bash with the -c flag, bash again, -i to make it interactive, and then /dev/tcp, our IP address of our command and control server, and the port. This will cause the system to generate an outgoing connection to the IP address we specify. And any commands we execute will be piped to bash interactively and executed. So now we have an interactive remote shell running outside the context of the sandbox. And as I mentioned, we can now download and persist other binaries. And since the quarantine attribute is not set, or we can remove these, Apple doesn't check those binaries for the quarantine attribute. So what we would normally do is we would persist a backdoor or some second stage implant. So what I decided to do to kind of drive this whole thing home is to persist a repurposed, clearly not notarized version of Windtail, which is a rather prolific cyber espionage Mac. And as you can see on the Slack logs, working with one of my coworkers about this, I was really excited when this all worked. And Windtail persisted and then started beaconing back to our custom command and control server. All right, so let's begin wrapping this all up. So first, talk about the bugs and the fixes. I reported them both to Apple and Microsoft. Microsoft said, thanks, this is a known issue on the Apple side. And I kind of had to laugh when I was like, yeah, because I told Apple. So Microsoft, as far as I know, didn't do anything. Apple said, thank you for the report, and then didn't say anything again. I followed up with them recently and said, hey guys, like, did you fix this bug? I'm going to be talking about a conference. It'd be great if this was fixed and users were protected. And they said, oh yeah, we fixed that in 10.15.3. So kudos to Apple for fixing that. But again, communications at the company level seems to be super one way. As far as I know, there's not a CVE, no credits, no bug bounty. Yeah, this is how Apple rolls. Wonder why security researchers don't like them. All right. Finally, what about detection? Well, if you're doing process monitoring, which if you're creating a security tool to detect intrusions and malware, it's probably something you should be doing. It's actually pretty easy to find the indicators of this exploit. So first, you will see Microsoft Office spawning curl and Python. This should never happen, right? Office documents should not be randomly spawning, at least definitely not curl. Python, very, very rarely. And if you're monitoring for persistence, you will see something persisting a zip file as a login item. That should raise all sorts of weird flags because, applications are probably the only thing that should ever be persisted. So like if you see a zip file being persisted, obviously that makes zero sense. Definitely something to take a closer look. All right, so that's a wrap. Today we started by looking at the current state of affairs in the world of macro-based attacks targeting macOS. We showed while they're growing in popularity because Macs are becoming more prolific, current attacks are rather lame. So what we did is we fixed that and we created a nice zero-click exploit chain that allowed us to infect fully patched macOS systems. So again, thank you so much for virtually attending my talk. We have 2 minutes and 11 seconds for any Q&A.
Unfortunately, that is going to be taken by me for setup time with the next speaker. But I have to say, this was quite an inspired little bug you found there.
Thank you so much. I appreciate it. If you have any questions, Patrick Wardle on Twitter, DMs are open. Shoot me a message there and we'll chat.